As the semester rolls on, we're getting to the point where we really should be working almost exclusively on the professional or the final paper for this course. So I just wanted to load up a quick lecture on producing a scientific paper. Regardless of what you do as a job with your degree, writing and producing scientific works are of extreme importance and probably the greatest skill that you need to be a consultant, you need to work in academia, to work for government entities, all that sort of stuff. So really it's of incredible importance. So I'll give you guys a few tips for writing your paper and go through a little bit about how I work through writing papers and reports, and then just talk a little bit about scientific graphics. So just to start, I hope you guys don't need me to repeat this, but there are most classes I do need to repeat this. Please do not turn in a first draft. Good writing takes time, and many drafts you have to go back, reread it critically. Make it concise. So when you're writing the paper, I think the key is to make your paper concise and understandable, yet engaging and easy to follow. And that is actually really hard with scientific papers that are really detailed and really complicated. But it's an important skill to be able to do. So when we write these papers, make sure that they have a story. The reader needs to be able to summarize your paper in a couple sentences, say why your topic was important, what you found, and why it matters. Not just a bunch of words and paragraphs thrown on a paper with no narrative beginning and end. So really think clearly about the narrative. Plan your paper. So the format. Most academic journals, which you guys have seen through taking this class, follow this format: abstract, introduction, methods, results, discussion, and conclusions. So for this paper, you don't need to have an abstract, and the conclusions can be tied into the last paragraph of the discussion, and that they should relate back to what the goal or the aim of the paper is. So remember, there's lots of steps in the writing process. Now you guys have already designed your projects, so some things you're kind of bound by. But really you should be writing, and for the last week or so you should be starting to write, do pre-writing, make notes, scribble ideas, draw out how you're going to write your introduction, what you think the results should look like, and then analyze, talk to people, bounce ideas off people, and then just start writing. Write the easiest section. I think the methods section, as you go along through analyzing your paper, start putting those in there. But remember that the methods section needs to be clear, concise, and easy to understand. Then you need to get into the revision stage. Work clearly through your revisions. Ask me for help. I'm more than happy to go through papers before they're due and give you feedback on what's in there, how the narrative flows, what your results are, all that stuff. And that's the aim of report 2, is to see what your introduction, your methods, your first results look like, and then get it all lined up so that we can work through this revision and editing and then proofreading. So just to go through the parts of the paper a little bit. So the introduction, the function of it is to establish the context of what you're doing, why you're doing it, and what we know about this already. At the end of the introduction should be your hypothesis, your questions, and it should be a real logical flow, because you've introduced the problem to us, you've told us what's known, and then you are basically stating what your objectives and your research are going to do here. Use the past tense and try not to use first or third person in this section. Remember to start broadly and end specific. I think of the upside down triangle. So if I use the project that's up on the website, how about road decommissioning, and highlight that we showed you guys a little bit about the roads up there, I think of maybe starting the introduction like this. General road ecology. What do we know about roads? Roads and forest ecosystems, especially the Intermountain West. The need to decommission them. How that may affect biodiversity, and what we know about road decommissioning effects on biodiversity, or the effects of roads on biodiversity themselves. Then your objectives and hypotheses, and then basically it would be 2 pages, double spaced, concise and clear. So the materials and methods section, this is where we need all the details to repeat the study, and you should describe how, and you should describe exactly how and with what you did everything. This section, the materials and methods, I often divide up into explaining the study site, how the plot data was collected, and then how the data was analyzed. Some diagrams can help, but don't get carried away. These will be your first. Usually there are not many things cited in the actual, or tables are not referred to and figures are not referred to very often in the methods section, but a diagram can help. And this section should be, again, 2 pages maximum, double spaced. Now we get into the important part, the results. What are your results? They need to be objectively presented without any interpretation. And always start simple and build to the more complicated results. The simple start should be obvious from what your objectives and questions are. And I follow the order of the objectives and questions that I laid out in the end of the introduction when thinking about the flow of the results section. One very important thing is report the ecological science first, not the statistics. Statistics are just there as some sort of confirmation in parentheses. The pattern should be relatively obvious. For example, if I were talking about road decommissioning in Highlight Canyon, and I was comparing ripped and seeded richness to controlled richness, I would say the plots within the ripped and seeded treatment had a lower diversity on average than plots within the controlled site. Parentheses, the 2 means of the statistics, or highlight a table where I could find it, and then an associated p-value. Don't write there was a significant B, blah, blah, blah. Don't start the sentence with statistics. Start the sentences with ecology. And present, I already said this, but present in the same order as given in the methods and the end of the introduction, where you state your hypotheses and your questions. And make sure there's a logical flow of the tables and figures so you don't have to jump back and forth. This section of the paper should be about 3 pages double spaced. So this is one of my favorite areas when I think about designing and working on the paper, and it's making a really good graphic that can communicate the story easily. When I read papers, I look at the abstract, then I look at the figures, and then if I'm further interested in the paper, I might read the discussion and conclusions, otherwise I sort of give up. So really, the figures are an important mechanism. And the figures are strongest when the reader can just look at them and understand the story. And there's serious research that goes on to understanding what makes a good graphic and communicating a story. Visual communication. This is what I do sometimes. I just give my figures to someone and say, hey, do you see the pattern in these figures? Could you see the story that I'm trying to get at in these figures? Test it on some colleagues, test it on some friends. So, types of graphs. X and Y plots are good for continuous data. Those, for example, some of the logistic regression curves that we've done. The graphic here below is a percentage germination at certain temperatures by different regions. Box plots are for categorical variables with discrete levels. So you have to be creative. There are some really awesome graphics out there in the modern computing age. There's a really good TED talk by a Swedish public health official that shows trends in human reproduction rates and GDP around the world. You can Google that. You can look for good scientific presentations on the web. There's some really amazing things that people can do with graphics now. So there's just an example of box plots. We've already done quite a number of these, so I'll just keep on going. I'll keep moving on. So here is the example of the best graphic created in the 19th century and on into the 20th century. It's often used as an example of an excellent scientific illustration and graphic that conveys data. So for all of you who may or may not know War and Peace, War and Peace was written by Tolstoy, a Russian author, and it's basically the story of Napoleon's invasion into Russia and the wars that go on with it. It's an amazing book, great description. I highly recommend it. I've read it before. But there was a guy in 1869 named Charles Minard, a French engineer, civil engineer, who produced a graphic that can tell the whole story of War and Peace in one graphic. War and Peace is like a 1,000-page book. And it's the example of Napoleon's campaign into Russia. So here it is here. So the four main variables in here are troop size, temperature at each site, time, and location. So he brought four variables together in a two-dimensional graphic. So on the left side here, you can see this is crossing the border out of Poland, I believe, into Russia, parts of Russia at the time. This line here the tan line is the size of Napoleon's army as he attacked into Russia. The black line is Napoleon's retreat. And you can see the dates are on here in Roman numerals. So this is, let me find my mouse. Here we go. We have October, and so the 10th month, and then as it keeps going across, and the temperature minus 26 Celsius, minus 30 Celsius, well below zero in the winter of 1812 and 1813. So the width of the line is the size of Napoleon's troops, 424,000 soldiers when he crossed the river. He attacked all the way to here, Moscow, and then retreated all the way home. And by the time he crossed back over, he had 10,000 soldiers left of 424,000. And he was captured then on the border of East Germany and Poland a short time later. So you can actually draw this in R, and I quickly recreated it in R as part of a class with his attack and retreat. And then you see the longitude here and the latitude defining his exact position. So it's basically a map. And then the size of his force, like I explained on the other graphic, and the temperature as it dropped throughout the campaign. On the 7th of December, it was 25 degrees and the position where he was at. So that whole graphic conveyed a whole story. Pretty compelling story. So I just want to go say a few things about my pet peeves when you're writing the paper. Never start a sentence that has the passive voice table 1 says. Put the ecology first. The mean abundance in the ripped and seeded roads, or the mean richness in the ripped and seeded roads was 25 species compared to 20 species sampled on average in the control sites. Don't just say table 1, see table 1 for the mean values of this and that. You need to write the story in a narrative and tell me what is important. And remember to think about your significant digits and your decimal points. How many significant digits do you have? How many decimal points are you reporting? So then I guess I'll move on. I'll talk a little bit about the discussion. So the discussion should be presented in the same order you have the intro, methods, and results. From large to fine, always put the ecology first. Here I shouldn't have to worry about reading any statistical blah, blah, blah. The function of the discussion is to interpret the results that you just objectively presented in the results. And you want to put that in the context of what is known and the context of your hypotheses. Quite often the discussion will have an introduction paragraph that kind of sums up the main points, and then you can move into detail. So think of these questions for the discussion. How did your results answer your hypotheses? Do you reject or accept hypotheses? How did the results compare to other findings of other studies? So putting your work in context of others. And then citing references that go on there. And remember to focus on the ideas, not the author. So for example, don't say XY found this, blah, 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 and we found this, blah, blah, blah. Talk about the results without referring to the authors and cite it at the end of the paragraph. And use the active voice but past tense in this section. So the discussion kind of starts out like the reverse triangle. It basically starts specific, talking about your specific results in the context of others in the context of your hypotheses, then expands out and puts it in context of the literature that's known, and then generally what it means. And always end your discussion with a summary, a basic, clear summary and conclusion of your work. And then restate simply the most important and basic finding in a positive manner. People often read the final paragraph. This should be ideally 2 pages double spaced, but if it stretches into 3, that's okay. You don't have to put in an abstract, but it's usually the last thing that's written, and it's basically 200 to 300 words. That's the aim, the location, the methods, results, and main conclusion. Sometimes you could write a rough draft of an abstract that really lays out your paper for you, so you have all this in just 200 to 300 words, and then you can expand on it. You could definitely write a rough abstract for the pre-writing or early writing phases to help guide you on how to structure your paper and define the narrative and set the narrative. You guys can work on graphics together, but I think you've all basically worked on individual projects. All the parts should be individual. Make your paper 1.5 to double spaced, 10 pages, I say 8 to 10 pages rather than 8 to 12 pages. I really want you guys to concentrate on writing concise, informative works. And 5,000 to 8,000 words is a little much. How about 3,000 to 5,000? But it can go to as much as 8,000 words. And that's not including the literature cited. You can use the APA style or the MLA style for references, or just look in your favorite scientific journal. But include a literature cited section in all your papers. And if you need help looking for literature, let me know. I have a feel for a lot of the topics out there that you guys are working on, and I at least have some examples or some places to start looking. So if you have any more questions, post them on the discussion in D2L, and I look forward to seeing all your work.